buoyancy. Look at this picture. The point where the force of buoyancy is applied, or the point on the object where the force acts, are termed as the center of buoyancy. That the force of buoyancy is a vertical force. You can see here. And thus, the center of buoyancy is the point situated at the center of the gravity of the liquid, that is, being displaced by the object submerged. Can you tell me why a ship made of iron floats while an iron needle sinks? See here, in the case of ship, which is hollow from within, the weight of water is displaced by the ship is more than the weight of the ship. Hence, it floats. Another case, we can take it as an example of iron nail. See here, iron nail which is compact, the weight of water displaced by it is much less than its own weight. Hence, it sinks. You can see these two pictures. What do you observe from this? Can you tell me? Yes, I can answer you. See here, upward force. Here two beakers are there. In first beaker, the objects submerged, partially immersed, we can say. The weight of the liquid and weight of the object. Here the buoyant force acting upward direction. The weight of an object is acting downwards. In second beaker, the object sinks. Here the weight of an object acting downwards. Buoyant force also acting upwards. But what is the difference between these two images? So first beaker, there is no net force acting on it. In second case, in second object, here there is a net force acting on a liquid. And next topic is lactometer. So before enter into the definition or uses, I just make you to understand what is meant by lactometer and where they are using and where it's applicable. Let's see. A lactometer is an application of hydrometer. You can see here hydrometer. It is used to check purity of cow's milk. It works on the principle of Archimedes' principle. See here, this instrument is graduated into 100 parts. As you know, milk is poured in and allowed to stand until the cream has formed. Then the depth of the cream deposit in degrees. Determine the quality of the milk. If the milk samples is pure, then the lactometer floats on it. And if it is adulterated, what is meant by adulterated? That is impure or impure. Then the lactometer sinks. So what do you have to observe? The relative density of milk does not give a conclusive indication of its composition. Since milk contains a variety of substances that are either heavier or lighter than water. An instrument to find out the content of the water in the milk or to test the richness of the milk is thus termed as lactometers. The lactometer works on the principle of gravity of milk. The construction of this instrument is very, very unique, as there is long vessel, test tube, and it has meter bulb. You can see here. The graduation ranging from top, that is 15, to at the bottom of the reading is 45. At the bottom of the reading is 45. Attach it to it, so that whenever the milk is poured into the vessel, the meter bulb starts floating on it. The purity of the milk gets tested without any dilution or water content in it. The correct lactometer reading is obtained only at the temperature of 60 degrees Fahrenheit. The average reading of normal milk is 32. And this type of lactometers are known for precision design, accurate measurements, and reliability. The lactometers are used highly at milk processing units and at dairies. The various types of the lactometers are mercury coated lactometer. You can see here mercury coated lactometer, which is highly for its precision design and its efficiency. The other type of steel ball lactometer, which is for its accuracy and it's for longer working. So lactometer consists of test tubes and meter bulb, which are the two main parts of the lactometer. The various parts of the lactometers are lacto jars, which are made from stainless steel. So lacto jar are made from plastic fossil type of lactometer. So these lactometers offer accurate results and are very much appreciated for long-lasting performance. So lactometers are very much used for industrial purposes, where the milk which is manufactured is tested first and then is sent to various products. Today we drink milk. Why we have to take milk? It's to remain fit and healthy. But we do not get to know whether the milk is adulterated with water or not. Thus, to testify the same thing, use of lactometers are very effectively method. Most of the milkman, what they will do? I think probably most of you know. Most of the milkman mix water in the milk by reducing the contents of rich milk, which only are essential for our body. To avoid the mixing of water in the milk, lactometers are very much used and have gained importance. So that we should learn what is meant by lactometer and how it's applicable. So the lactometer measures the cream content of milk. The more cream the lactometer, the lower the lactometer floats in the milk. The hydrometer is based on Archimedes' principle only. Do you know how? That a solid substance suspended in a fluid will be bound up. That is nothing but Bion's force. By a force equal to the weight of the liquid displaced. Thus, the lower density of the substance, the further hydrometer will sink. Hydrometer consists of a cylindrical stem having a spherical bulb at its lower end and a narrow tube at its end. The lower spherical bulb is partially filled with lead shots or mercury, Why we have to use mercury here? Because this helps hydrometer to float or stand vertically in liquids. So the liquid to be tested is poured into glass jar. The hydrometer is gently lowered into the liquid until it floats freely. Hydrometers may be calibrated for different uses, as I said earlier, such as lactometers for measuring the density. So measuring density means here what is that? Creaminess of milk. And saccharometer for measuring the density of sugar in a liquid. And alcohol meter for measuring higher levels of alcohols in spirits. So it is used to take direct reading. So we can call it as a direct reading instrument. It is used for measuring the relative density of the liquid. Is called hydrometer. So hydrometer is based on the principle of flotation also. Now you should understand why we have to learn the concept of flotation, concept of Archimedes principle. Now it's very easy to understand. That is, the weight of the liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. So it obeys the laws of flotation. And next topic is Cartesian diver. What gas law in the Cartesian diver? The Cartesian diver by Pascal's principle. In previous class, we had a discussion about Pascal's principle. So here applicable of Pascal's principle, that the pressure is transmitted to all parts of the container. I can say good example of Pascal's principle, that is, it can be observed in hydraulics as we discussed. So what is the example? Cartesian diver is positively buoyant force. How we can say positively buoyant force? So Cartesian diver, it's nothing but floating at the top. So positive buoyant force means floating at the top. If pen cap with the clay floats on the water, when the bottle is squeezed, the water exerts pressure in all directions and the cap becomes negatively buoyant, sinking to the bottom. When the bottle is released, the pen cap becomes neutrally buoyant again, raising to the middle of the bottle. How the Cartesian diver works? There is air inside the diver, that is pen cap. You can consider making it positively buoyant, so it floats on the top. When the bottle is squeezed, pressure is exerted on the water. This pressure is exerted in all directions and it increases the pressure on the air bubble inside the diver, that is pen cap. The air inside the diver, that is your pen cap, compresses and reduces in volume. It's allowing more water to enter the diver. Let's see what is Archimedes' principle. Before enter into this definition, we can do an activity. Take a piece of stone and tie it to one end of the rubber string or spring balance. Suspended the stone by hitting the balance or the string. Note the elongation of the string or the reading of the spring balance. Due to the weight of the stone, now slowly dip the stone in the water in a container. What do you observe? So observation, what happens? The elongation of the string or reading of the balance. You will find that the elongation of the string or the reading of the balance decreases. As the stone is gradually lowered in the water. However, no further change is observed here. Once the stone gets fully immersed in the water, what do you infer? From the decrease in the extension of the string or the reading of the spring balance. We know that the elongation produced in the string or spring balance is due to the weight of the stone. Since the extension decreases once the stone is lowered in water, it means that some force acts on the stone. That force we call it as upward direction or upthrust force. As a result, the net force of the string decreases. That depends on the stone gets lowered. Hence, the elongation also decreases. As discussed earlier, this upward. So, formula of Archimedes principle is FB equal to WA minus WF. So, FB is again to the buoyant force on the object, and WA is the normal weight of the object measured in air, is nothing but what? WA is equal to mg, we can say. And next, WF. WF is the weight taken while the object is immersed in a liquid or fluid of its density. So, how to verify the Archimedes principle? So, take a eureka can and filled it with up to spout. Take a stone and suspend it with the hook of the spring. Hook of the spring balance. Note that the weight of the stone in air, let it be W1. Now, immerse the stone inside the water in the eureka can. The water overflows throughout the can. Now you can collect this overflowing water in the beaker. Now also note the reading in the spring balance. That reading is, let it be W2. This W2 will be less than W1 due to upthrust provided by water. Apparent loss in weight due to upthrust will be W1 minus W2. Hence, the Archimedes principle is verified. So, applications of Archimedes principle. It is used in designing ships and submarines, used in making lactometers and to determine the purity of milk, and used in hydrometers and determining the density of liquids. Applications of laws of flotation in everyday life. In transportation by waterways, the law of flotation is applied in all vessels which travel by waterways. That includes ships, submarines and ferry boats. In transportation by airways, it is also applied in some vessels which travel by airways such as hot air balloons and airship. In decoration, balloons of different colors and shapes are filled with lighter gas, so that will float in air. In measurement of specific gravity of liquids, hydrometer is an instrument which is used to measure specific gravity of liquids in its to employ the law of flotation. An interesting topic is buoyancy. On the festival time, Shiva buys some balloons. he observes that the air-filled balloons are floating on water, while water fluid balloons sink at the bottom of the bucket or beaker or any other vessel. So he asks her elder sister about it. She tells him that floating and sinking of the balloons is due to buoyancy. Let's study about buoyancy and what is buoyant force. Have you ever had a swim in a pool and felt lighter? Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Have you ever wondered why a ship made of iron and steel does not sink in seawater, but while the same amount of iron and steel in the form of a sheet would sink? These questions can be answered by gravity versus buoyancy. Which one wins? Let's see. Think of gravity and buoyancy as two opposing forces. Gravity pulls down, buoyancy pushes up. If weight, that is nothing but gravity, is greater than the displaced water, so displaced water is your buoyancy, the object will sink. If the displaced water buoyancy is greater than the weight of the gravity, see, from this you can understand the buoyancy concept of, it can be negative buoyancy, positive buoyancy and neutral buoyancy. If the weight of the object is greater in first case, so the object will sink. That is called negative buoyancy. In second case, the weight of an object is less dense, so the object will float. That term is called positive buoyancy. And see the last case, the weight of an object is neutral. If the weight of an object is floating, can you see here? So this is called neutral buoyancy. So let us understand the meaning of buoyancy by doing an activity. Take an empty plastic bottle. Close the mouth of the bottle with an airtight stopper. Put it in a bucket filled with water. You see that the bottle floats. Push the bottle into the water. You feel an upward push. Try to push it further down. You will find it difficult to push deeper and deeper. This indicates the water exerts a force on the bottle in the upward direction. The upward force is exerted by the water goes on increasing as the bottle is pushed deeper till it is completely immersed. Now release the bottle, it bounces back to the surface. Why objects floats or sinks when placed on the surface of water? Let us do the following activities to arrive at an answer for this question. Take a beaker filled with water. Take an iron nail and place it on the surface of the water. What do you observe? The nail sinks. The force due to gravitational attraction of the earth on the iron nail pulls it. downwards. There is an upthrust of water on the nail which pushes it upwards, but the downward force acting on the nail is greater than the upthrust of water on the nail. So it sinks. Force exerted by water is known as the force of buoyancy. What is the magnitude of the buoyant force? Is it experienced by a body? The same in all fluids for a given body. Do all bodies in a given fluid experience the same buoyant force? The answer is it's stated by Archimedes' principle. When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. From this, what you have learnt? All objects experience a force of buoyancy when they are immersed in a fluid. Objects having density is less than that of the liquid in which they are immersed float on the surface of the liquid. If the density of the liquid is more than the density of the liquid in which is immersed, then it sinks in the liquid. See, in last case, the object buoyant force is equal, so that we call it as neutral buoyancy.